Hey folks, here's a tutorial for Lab 2. You will need to use the written instructions in Canvas because I ask you to write some things about what you're hearing and capture or record audio examples into Logic for me to listen to. That's what you're getting graded on. The rest of it, where I'm explaining what to patch and settings, you can use this if you want, or I will quickly go through it here. What you're looking at is basically 4 screenshots. It's really 3 because this adds only 1 cable. So I will go through, quickly patch each one. I am in a bit of a hurry, so I'm going to go a little bit fast. First, a little bit of information I want you to know. For the rest of the semester, please think of this as VCO1, VCO2, 3, 4, 5, 6. VCOs 3 and 4 each have a Q141 oscillator aid next to them. The Q141 is not a standalone module. There's no circuit board behind it. It only functions with a Q106, breaks out some additional functions. It's really cool, especially when using it as an LFO. It's neat, and that's what you will be doing. This is the Q128 voltage-controlled switch. We're going to be using that. It has 2 sections, switch 1 and switch 2. And they both work. They're both bidirectional, so you can bring in a signal into A and a different one into B and get one of them out of the common depending upon the control jack at the bottom, or you can go in the reverse direction. We're going to go in the first example. We're going to feed sounds from each oscillator into A and B and then only have one of those sounds at a time come out the common. Here's a quick comment for you just so you know. This is a sequential switch. A sequential switch is a little different. 2 or more inputs that go to an output, and which input is routed depends on the shift input getting a pulse or trigger, and then it holds that until it receives another pulse or trigger. The voltage controlled switch is different. When you have voltage coming into the control, it's in state 1, and when it goes to 0 volts, state 2. So it's not like you can send it gates like a sequential switch. It's neither better nor worse, just different. We're also going to use this 526 mixer. We have 3 mixers, 1, 2, 3. They're all different. They each have their charm. I like the 526 a lot for some things because it has on-off switches and the controls are bipolar. So we're not mixing control voltages with it. But when I do mix control voltages, I almost always use that one because it's convenient to be able to reverse them. Just so you know, we are not patching the pitch output of the interface. These oscillators will just be droning, not tracking the keyboard. Also, we won't be sending an envelope generator into the VCA. We're just going to manually turn this up so that you can hear it when you need to. Okay, here is the patch. You're going to take the wave output of VCO1 into jack A of switch number 1. You're going to take the wave output of VCO number 2 into jack B of switch number 1. Then you're going to take the common, which is the output in this case, into input of mixer channel 1, output of the mixer, into the signal input. Then the next thing you need to do, the last thing, is because we're using square waves, you could literally use either of these. I just typically take the positive output and plug that into the control input. Quick settings here. You're going to set oscillator 1 straight up for both coarse and fine, waveform triangle, and you're going to set oscillator 2 about an octave up, roughly. Just tune them somewhat, will you? And triangle wave also. The 526, because they're bipolar control, straight up means it's off. All the way over here is full on, all the way over here is full on, but out of phase. So turn this up until you hear one of them. Now, you need to set this as an LFO into low range and set the speed somewhere in there, about 6 or 7. Make sure you start off, and the instructions are in there, I forget. I think it says start off with this set to square wave, and this will be going back and forth, whatever the interval is. Then what you're going to do, read the instructions, please, is you are going to modulate both. Well, first you're going to modulate the volume output, which is this knob here, and it's a hardware switch, man. It's a little squirrely. I cannot find anything digital or soft synth that emulates the behavior of a number of real things that happen in a modular, and this is an example. It's not entirely clear exactly what's happening all the time, which you will see. So while it's going back and forth between oscillator 1 and 2, play with this level control, record some of that in logic. Then I think I ask you to switch this from square to pulse. Remember, a square wave is a pulse wave with a 50% duty cycle? Here's the point and how this is wired. I'll come down here because there's not a cable in the way. When this is in square, you can move this width control all you want. It has no effect. It's permanently 50%. When you switch this to pulse, now the width control has an effect. So when you're up here experimenting and listening, besides changing the level, after using it as a square wave only, change this to pulse and then mess around with the width and change the level. That's version 1. Version 2 is very simple. All it adds is a single cable. You're going to go to the MIDI interface, take control output 1 and plug it into the LFO exponential variable input. Make sure that the mode switch is set to 3 and the variable exponential level, set it somewhere in the middle for now. If you haven't already, turn on the VFX keyboard. Power switch is on the back, right where it says power. When you turn the power on, don't touch the keyboard. It has to scan and calibrate. It'll be fast. Once you've turned the VFX on, hit some keys and confirm it's sending MIDI because the gate light should light up. If it doesn't, go to the little half-rack roll-in box that's up all the way on the top of the synth and make sure switch number 1 is pressed. Now, when you turn the modulation wheel on the VFX, it will be sending a control voltage here and changing your speed. So adjust both this and this so that you can get a nice range of speeds. Then what you do is you move the mod wheel with your left hand while you take your right hand and change the level and or the pulse width to hear the effects of all these changes going on there. That's version 2. Screenshot version 3 here is fun. This is what you do. This is the Q110 noise module. Make sure the volume is all the way up. I don't even know why I put it in there. I never change it. Maybe someone does. Take the white noise output into the fixed filter bank low input. I will call this the FFB for the rest of the semester. You have a whole bunch of bandpass filters with individual level controls, separate outputs for both the odd and even cells plus the whole filter bank, and then, really cool, individual outputs. The volume of these band-limited outputs are not affected at all by the settings of these knobs. Take 1K, bring it out into the mixer channel 2. Turn off channel 1 so you're not hearing the VCOs. Turn this on so you're hearing a 1K noise through here. Then kick Logic into record and unplug this and plug it into different ones. So I know that you are hearing band-limited noise at different bands. That's 3. Then the fourth and last one is take that 1 kilohertz and plug it into switch number 2, jack B. Then take something like 2.8K, plug it into switch number 2, jack A. Then take the common, which is the output of either of those noise bands, and bring it down into channel 2. Now, listen to the sound of the 2 different noise bands being modulated by the LFO. While you're hearing those noise bands, put Logic into record, modulate the speed of the LFO, modulate the amount of the signal level output of the LFO, and the pulse width. Then, after you capture some of that, turn channel 1 back on so you have the VCOs and the noise, and capture that. So there's the lab.